Hi everyone, this is Michelle, and I will be giving an overview of how to combat AP and IB chemistry in my class. As a teacher who studied the rigorous IB diploma program at the American International School, the ultimate goal of my class is help you achieve the best results in your AP, IB, and school exams. We will intensively cover all the areas of IB and AP objectives based on your school curriculum. So first of all, let's take a look at some IB objectives. We will be learning quantitative chemistry, atomic structure, periodicity, bonding, energetics, kinetics, equilibrium, acids and bases, oxidation and reduction, organic chemistry, measurement and data processing, as well as analysis. Next, these are the AP objectives, and in fact, they have a lot in common. We will learn atomic structure and properties, intermolecular forces, molecular ionic compound, chemical reaction, kinetics, thermodynamics, equilibrium, acids and bases, and thermodynamics and its applications. Moving on, I'll illustrate some big concepts that are essential for education. So this is an image of the electron domain geometries that you will learn in chemistry. The number of electron domains, 2, 3, 4, 5, 6, are listed on the left-hand side. And on the right-hand side, you can see that there are electron domain geometry given as linear, trigonoplanar, tetrahedral, trigonal bipyramidal, as well as octahedral. Using this concept, we can draw the Lewis structure of this molecule of SnCl3. The central Sn atom is bonded to the 3Cl atom and has one non-bonding pair. Thus, we have 4 electron domains, meaning a tetrahedral electron domain geometry, with one vertex occupied by a non-bonding pair of electrons. A tetrahedral geometry with 3 bonding and 1 non-bonding domain leads to a trigonal pyramidal molecular geometry. Next, let's take a look at another big concept. The second key concept is about atomic and molecular weight and how it can be measured using a mass spectrometer. The spectrum of chlorine showing 2 isotopes is seen on the right-hand side, and you can also measure the abundances. Utilizing this, let's take a look at the applications. Naturally occurring chlorine is 75.78% of 34.969 EMU and 24.22% of 37Cl, 36.966 to be more specific EMU, and your goal is to calculate the atomic weight of chlorine. In order to solve this, we can calculate the atomic weight by simply multiplying the abundance of each isotope by its mass and summing these products. And therefore, when we add 26.5 plus 8.95, we are able to derive the answer, which is 35.45 EMU. Moving on, this is a structural question that we'll see normally in paper 2. The sulfur atom is in light gray, carbon atom is in dark color, oxygen atom is in white. So the question is, in terms of the types and relative strength of all the intermolecular forces, explain why CS2 has higher boiling point than COS. And for part B, what is the pressure in the container once all of the CS2 has vaporized? Okay. So moving on, let's take a look at the solution. CS2 has only London dispersion forces, or LDF, while COS has London dispersion force and dipole-dipole forces. Because LDF are stronger than the combination of LDF forces and dipole-dipole force in COS, we can gain this answer. And for part B, we simply have to use P equals nRT divided by V to find the pressure, which is 0.7 atm. To conclude, our process is very easy. Through the course content, you will gain knowledge and you will focus on your individual area of weaknesses to finally result in your highest achievement. Thank you for listening and find Michelle. I hope to see you guys in class.